AI is everywhere. Your phone, your car, your smart speaker. It's woven into the fabric of our daily lives, often in ways we don't even notice. From unlocking your phone with your face to getting directions or asking your smart speaker to play music, AI is quietly working behind the scenes. But what actually powers all this intelligence? The answer: AI chips. These tiny pieces of technology are the engines that drive modern artificial intelligence. Regular computer chips, or CPUs, are generalists. They're designed to handle a wide variety of tasks, from browsing the web to running spreadsheets. But when it comes to the massive data and lightning-fast calculations that AI demands, CPUs just can't keep up. They handle lots of tasks, but not at the speed or scale AI needs. AI chips are specialists, built for one thing: running artificial intelligence tasks. They're engineered to process huge amounts of information in the blink of an eye. Imagine trying to solve thousands of math problems at once instead of one after another. A CPU does them one by one. An AI chip does them all simultaneously. This is called parallel processing. It's like having a whole team working together instead of just one person. That's why AI chips are crucial for complex tasks like language understanding, image recognition, and even real-time translation. They make it possible for AI to analyze huge data sets and make sense of the world around us. They're the hardware foundation that lets AI models run smoothly and quickly, powering everything from cloud services to personal devices. Without them, asking an AI to write a story or create an image would take hours, if not days. With AI chips, these tasks happen in seconds. The rise of powerful AI chips has turned science fiction into reality. Robots, smart assistants, and self-learning machines are no longer just dreams. They're here now. These chips are the unsung heroes, making our technology smarter and more capable, quietly working behind the scenes to enable breakthroughs. When we talk about AI, it's not just clever code, it's also the hardware bringing it to life. The software and the chips work hand in hand. These chips are getting more powerful every year, pushing the boundaries of what technology can do and opening up new possibilities. They're at the heart of the tech revolution, from self-driving cars to advanced medical diagnostics and even smart factories. Understanding these chips is key to understanding where AI is headed. The future of technology depends on how these chips evolve, and right now, there's a huge battle brewing between the companies that make them. The race to build the best AI chip is fierce and global. Let's dive into that showdown and see who's shaping the future of artificial intelligence. Now let's dive into the software side of things, specifically DeepSeek R1, the latest breakthrough in artificial intelligence. DeepSeek R1 is what's known as a large language model, a kind of digital brain that's been trained on an enormous collection of text, code, and information from across the internet. By analyzing this vast data, it learns patterns, grammar, facts, and a wide range of writing styles, which allows it to generate text that sounds remarkably human. With these skills, DeepSeek R1 can write emails, summarize lengthy articles, answer questions, and even generate computer code for developers. But to accomplish all this, it needs to process and analyze huge amounts of information at lightning speed. There's no room for lag. When you type in a question, DeepSeek R1 isn't just pulling a pre-written answer from a database, it's actually generating a unique custom response for you in real time, tailored to your query. That kind of instant, intelligent reply requires some serious computational muscle under the hood. The bigger and more advanced the model, the more demanding it is on the hardware that runs it, meaning it needs the fastest, most capable chips available. Fast, efficient chips mean a snappier, more responsive AI, which translates to a smoother and more enjoyable user experience for everyone. For businesses, speed isn't just a luxury, it's essential. Delays or slowdowns can lead to lost customers, missed opportunities, and reduced productivity. The choice of chip determines not only how fast the AI can think, but also how much it costs to run, and ultimately, how good the final product will be for users and companies alike. That's why the ongoing battle between Nvidia and Huawei to power DeepSeek R1 is so important. It's about who can deliver the best performance at the right price. So let's take a closer look and see which company has built the best brain for the job and what it means for the future of AI. In one corner, we have Nvidia, the longtime king of AI chips, a company that has shaped the very foundation of modern artificial intelligence hardware. Their GPUs, which were originally designed for high-performance gaming, turned out to be perfectly suited for the complex calculations required by AI and machine learning. Today, Nvidia's Hopper architecture featuring the powerful H100 and H200 chips, is considered the industry standard. This dominance is reinforced by a mature, robust software ecosystem that makes it easy for developers to build and scale AI solutions. In the other corner stands Huawei, a telecom giant that has rapidly transformed into a serious AI hardware contender thanks to its cutting-edge Ascend 910B chip. Out of necessity, Huawei developed its own high-end AI technology, building from the ground up with its DaVinci architecture, which is designed purely for AI workloads and optimized for efficiency. Both companies are racing to process massive AI workloads as quickly and efficiently as possible, pushing the boundaries of what's possible in artificial intelligence. Nvidia's approach is to build powerful, general-purpose AI accelerators, supported by a huge global developer community and a vast array of software tools. Meanwhile, Huawei focuses on a tightly integrated system, designing not just the chip, but also the software and networking, all in-house, to achieve maximum efficiency and seamless performance. Nvidia is the established leader, but Huawei's focused, vertically integrated approach is showing real promise, especially for training and running large models like DeepSeek R1 and other next-gen AI systems. It's a classic battle, dominant incumbent versus hungry challenger, each pushing the other to innovate faster. Huawei's vertical integration allows them to fine-tune every part of the system, from hardware to software, giving them unique control over performance and efficiency. While Nvidia's chips are widely adopted across industries, Huawei's approach is rapidly gaining traction, especially for specific, large-scale AI models and enterprise solutions. The stakes are high. Whichever company comes out on top could end up powering the next generation of AI breakthroughs, shaping the future of technology itself. So, how do these two giants really stack up when it comes to performance, efficiency, and innovation? Let's take a closer look. The competition is heating up, and the world is watching to see who will lead the AI revolution. For massive models like DeepSeek R1, speed is everything. Inference speed, to be exact. Recent tests show Huawei's Ascend 910B can match or even outperform Nvidia's H100 in some scenarios. For example, generating a long text might take Huawei's chip 8 seconds, Nvidia's 10. That difference adds up fast at scale. Millions of users, millions of requests. Faster chips mean more users served, better experiences, and more efficient operations. How does Huawei do it? Their DaVinci architecture is tailored for the math large language models need. Huawei's complete ecosystem, from software to high-speed interconnects, eliminates bottlenecks. Nvidia's chips are more general purpose, which can mean less optimization for specific workloads. For Huawei, this is a major win, especially after being cut off from top-tier international tech. Their focused in-house development is paying off. For DeepSeek R1, the synergy between software and local hardware is a powerful combination. It's a new level of performance and independence. Speed is great, but efficiency is just as important. AI chips consume massive electricity and generate heat. Energy costs can skyrocket in data centers. Huawei's Ascend 910B was engineered for extreme power efficiency. It does more work with every watt, often using less power than Nvidia's H100 for the same task. Multiply that by thousands of chips and hours, and you save millions on electricity. The secret? DaVinci's specialized AI cores designed for the math neural network's use. By stripping away unnecessary components, Huawei dedicates more resources to what matters for AI. Less wasted energy, more precise performance. For companies running DeepSeek R1, this means lower costs and a smaller environmental footprint. Efficient chips make AI services cheaper and more sustainable. In the long run, the smartest AI platforms will also be the most efficient. Here, Huawei's power per watt focus gives it a clear edge. Efficiency is the new battleground. Let's talk cost, the ultimate deal breaker. Nvidia's H100 chips are the gold standard, but they're expensive, tens of thousands of dollars each. Building a cluster for DeepSeek R1 can cost millions. Huawei's Ascend 910B comes in at a much lower price point. Reports suggest thousands of dollars less per chip. For companies buying in bulk, this is a game changer. Huawei's in-house development and control over its supply chain keep costs down. They're trading profit margin for market share, making their chips highly attractive. The result? Competitive performance, better efficiency, and a much lower upfront cost. For scaling up AI, Huawei's value proposition is hard to beat. The price war is on. What's Huawei's secret? The DaVinci architecture. Unlike GPUs adapted for AI, DaVinci was built from scratch for machine learning. Its AI cores are specialized for matrix multiplication, the math at the heart of large language models. Dedicated hardware means faster, more efficient processing. Huawei controls the whole stack chip software, CAN, and high-speed networking. This vertical integration eliminates bottlenecks and maximizes performance. For DeepSeek R1, developers can fine-tune the model to run perfectly on Ascend hardware. It's like designing a race car where every part is optimized for one track. This level of co-optimization is hard to match in Nvidia's broader ecosystem. For DeepSeek R1, Huawei's synergy is the secret sauce. That's how they unlock top-tier performance. Why should you care about this chip battle? It directly affects the AI tools you use. Cost, speed, and quality. Huawei's affordable, efficient chips mean cheaper and better AI services for everyone. Competition drives down prices and prevents monopolies. It also fuels innovation. Nvidia and Huawei are pushing each other to make better, faster chips. This arms race leads to smarter, more capable AI year after year. Huawei's rise shows world-class tech can come from anywhere, not just Silicon Valley. That means more choice and a more resilient global tech ecosystem. For users, it's a win: better products, lower prices, and more innovation. The showdown shapes the future of AI for all of us, and the race is just getting started. So, who wins for DeepSeek R1? Huawei takes the crown. The Ascend 910B matches or beats Nvidia's H100 in speed and efficiency for this model. The secret is tight co-optimization, hardware and software working in perfect harmony. DaVinci's AI-focused design plus the ability to fine-tune DeepSeek R1 delivers top performance. The unbeatable value: fast, efficient, and much cheaper. Lower operational costs and a lower upfront price make a compelling business case. For companies deploying AI at scale, Huawei's offering is a massive advantage. It's a story of focused design and strategic execution. While Nvidia still dominates the broader market, Huawei is now a serious contender. For DeepSeek R1, Huawei's Ascend 910B is the smarter choice.